Welcome back for another fun lesson. This is going to be a math lesson, and we're going to be talking about some numbers or some special numbers and how we make note of that or write their symbols. And so I don't have the whole bead cabinet. I'm working here at home, and so I don't have all of the bead chains with me, but I want to start with a couple of the bead chain work things. And so I'm going to switch our view. And I want to talk about this bead chain right here. And I know that's a tricky one because it doesn't necessarily look like a chain. It looks like it could just be from the bead bar box. This is the one. This is the short chain of one. Can I build anything out of the short chain of one? Not really. If I had the short chain of two, we could try that. I don't have that one here at home. I do have the short chain of five here. If we look at this short chain of five, I have one group of five, two groups of five, three groups of five, four groups of five, and five groups of five. If I bend this around and make it into a figure, I make this into a five-sided figure. The five chain can make a five-sided figure. From our polygon work, maybe you know what a five-sided figure is called. A five-sided figure is called a pentagon. So a five-sided figure makes a pentagon. The other short chain that I have here at home is the nine chain. Here's our nine chain. Our nine chain has 1, 2, 3, 4, 5, 6, 7, 8, 9 groups of 9. 9 groups of 9. If I make this into a polygon, into a figure, and stretch it around, this becomes a polygon with 9 sides. And if you remember from our polygon work, a 9-sided figure is called a nonagon. Now, I wish that I had all the short chains to show you all of them, but we can make a prediction. If we know that a five-sided figure makes a pentagon and a nine-sided, if the five chain with 5 equal sides makes a five-sided polygon, a pentagon, and the 9 chain with 9 equal sides makes a nonagon, can we make an educated guess on what we think the other chains would make? If we had the 3 chain, and the 3 chain has 3 equal groups of 3, the 3 chain would make a 3-sided polygon, and a 3-sided polygon is a triangle. And if we had the 4 chain, a 4-sided polygon with 4 equal sides, we call a quadrilateral. So we could look at our chains in a new way. We can look at our chains and realize that we can make figures out of them. But that's not all we can do with our chains. Something else we can do, I'm going to pull our 9 one down here out of my way, and I want to look at our 5 chain. We know that this is 5 groups of 5, and we know that we can change this into a figure. The 1 chain, we can't change it. It's still just 1. But if we take this 5 chain and we fold it back on itself, if we fold it this way, and then this way, and then back that way here, we end up with another figure. Our short 5 chain, when we spread it out, can make a 5-sided polygon. Here, when we bend it all together, we make a 4-sided polygon. And this one's special. This one has a side of 5, and another side of 5, and another side of 5, and another side of 5. This makes a special kind of quadrilateral with all 4 sides being the same. This is a square. Our short chain of 5 could fold into a square with side lengths of 5. Now let's look at our 9 chain. What if we fold our 9 chain back on itself? There's 3, 4, 5, 6, 7, 8, 9. We folded our 9 chain back on itself 9 times, and we have a quadrilateral, a four-sided polygon with 9 on this side and 9 on this side and 9 on this side and 9 on the last side. The 9 chain, the short 9 chain, made a square with side lengths of 9. That's really cool. When we think about, we could use this, we could spread it out and make a 9-sided polygon, but if we fold it all in together, it makes a 9-sided square. I want to replace these two out. These are the chains. I want to replace them out with our fixed square so I can pick it up and manipulate it without doing this roll and making a mess. So I'm going to replace or not replace, but just set out the square next to it. So when we are looking at these pieces, we can call them a square. And a square is a really special thing. You know, mathematicians love to have their own symbols for all of their things that they do. So this one here has a side length of 5. And this other side is also 5. So when we have a side length of 5 and the other side length is 5, it's a 5 square, or it's a square made out of 5. And we could write 5 times 5. The way we find that the amount of beads in there is we have 5 groups of 5, or 5 times 5. And mathematicians love special ways of writing things. So this is the 5 square, and we find that by doing 5 times 5. But mathematicians have a special way of calling it a square. They do this. It's a big 5 with a little 2 up above. That little 2 up above says this is a square. And it says it's a square by saying it's 5 in 2 directions. 5 and 5. So this says multiply 5 times itself 2 times. 5 times 5. 5 squared. We call this number, the 2 up there with the square, we call that an exponent. All of this is the same. This square with sides of 5, we find by multiplying 5 times 5. We record it as saying 5 squared. And we can also solve the equation. What is 5 times 5? 5, 10, 15, 20, 25. The answer to this is 25. The value of the 5 square is 5 times 5. We can write that as 5 with an exponent of 2, 5 squared, and 5 times 5 equals 25. So that is how we talk about squares of numbers. I'm going to move our 9 chain off just like I did the 5. Here's our 9 square. And let's label this one together. So just like I labeled the 5 square, we're going to label this 9 square. Just getting a couple tickets ready. Okay. This bottom side right here, the base of this, has a side length of 9. And this side right here is also 9. We find the area or the space or how many beads there are by doing 9 times 9. 9 times 9 equals, let's do it in the way mathematicians like to do it. 9 times 9, or 9 squared, can be written 9 with an exponent of 2. 9 squared. 9 squared, or the value of the 9 square, 9 times 9. Maybe some of you know this. We'll skip count together. 9, 18, 27, 36, 45, 54, 63, 72, 81. The value of 9 squared is 81. 9 times 9, or 9 squared, equals 81. So we did those two together. Those were two of the examples, but you can do this work with all of the squares. I am going to, I don't want to mess this up, so I'm going to slide it out of the way, just over there. We can do this same work with our 1 square. Yes, this is a square of 1. It has a side of 1 and another side of 1. 1 by 1. 1 times 1 is 1 squared. 1 times 1 is 1. Here's our 2 square. 2 times 2, 2 squared. 2 times 2 equals 1, 2, 3, 4. I'm not going to do all of them for you, but we'll do a couple. Here's our 3. 3 square is 3 times 3. 3 times 3. Our 4 square, 4 times 4. 5. 6. Or 7, 8, 9, and our 10. Those are all of our bead squares. And so we can look at all of them. For your follow-up, in your journal, you are going to create a table of our, well, it doesn't have to be a table. You're going to create a squares of numbers example. And I will share a picture of this. So what I did is I drew the square of 1, there we go, the square of 1, and I wrote out the equation 1 times 1 equals 1 squared, and it equals 1. And you can see all of these examples. There's our 2 square, right there, and the 6 square, and the 7, and all of my examples. There's my 9 and 10. For your follow-up, you are going to do the same thing. You're going to create a page in your journal that has all of your squares 1 through 10, and it has the equations that we did together. So it's going to have, let me pull this back into our screen. Back into our screen right here. You're going to include all of this information. You're going to draw a 5 square. You're going to write the equation 5 times 5. You're going to write the exponent 5 squared and the answer 25. And you're going to do that for all of our squares 1 through 10. Don't worry, my journal will be there as an example for you to look at. So you'll be able to see all of those squares and the equations. I would like you to share a picture of this when you're all done. I can't wait to see your work with the squares of numbers and the first time we're writing with exponents in this way. And I hope you enjoyed that. I hope you learned something new. And I hope you realize that squares or numbers written this way don't have to be scary. I can't wait to see you next time. Bye-bye.